Hey there guys, Mrs. Matheson here. Welcome back to Unit 2, Notes 4, Proving Lines Parallel. Our learning target today is I know and can apply properties of parallel and perpendicular lines, including properties of angles formed by a transversal and their converse to solve problems and just logically justify results. So we're pretty much doing the opposite of Notes 1. Notes 1 said, hey, these two lines are parallel. Therefore, you know this about the angles. They're either congruent or they're supplementary. Well, today what we're going to see is we're going to see these angles are congruent or supplementary. So tell me what lines are parallel. Our first thing that we're going to talk about is our converse of corresponding angles postulate. It says if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So for example, if we look at angles 1 and angle 3, if those two angles are congruent, angle 1 is congruent to angle 3, then because they relate to A and B, we can say A is parallel to B. We also could have used like 8 and 6. Those are also corresponding. If angle 8 is congruent to angle 6, then A is parallel to B. So let's see that in an example. It says, given the following information, is it possible to prove that any of the lines shown are parallel? If so, state the postulate or theorem that justifies your answer. Angle 1 and angle 3. Those two angles I know are corresponding angles. And if those two are congruent, we can say A is parallel to B. But don't forget to state the postulate or theorem that justifies. Well, we only know one, and it's by corresponding angles. Corresponding angles postulate. So really, it's just knowing about our angle relationships. We also see parallel postulate. If a given line and a point not on the line, then there exists exactly one line through the point that is parallel to the given line. So if you have a point P and line M, there's only one line that's going to go through P. That's going to be parallel to M. All right, here's our page with some big definitions. We see first our alternate exterior angles converse. So as everyone starts with, if two lines are of a plane are cut by a transversal so that a pair of alternate exterior angles is congruent, then the lines are parallel. So we see 1 and 3, those are alternate on the transversal and they're on the exterior of those two lines. So those would make us say if angle 1 is congruent to angle 3, then P is parallel to Q. So let's look at our consecutive interior angles. So if we have a pair of consecutive interior angles that is supplementary, then the lines are parallel. Remember that if they're the consecutive, so comes right after another, and they're inside our two lines, those need to be supplementary. So if angle 4 plus angle 5 equals 180, then we can say the two lines, P and Q, are parallel. All right, two more. All right, it says that alternate interior angles converse. Blah, 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 about two lines on a plane. It says that the pair of interior angles is congruent, then lines are parallel. 6 and 8 are inside P and Q, and they're on opposite sides of the transversal. So if angle 6 is congruent to angle 8, then P is parallel to Q. This one's a new one, perpendicular. We haven't really talked much about that yet. In a plane, if two lines are perpendicular to the same line, then they are parallel. This one a lot of times kids see and think corresponding angles because we still are talking about corresponding angles. But what makes this one special is that it's a 90-degree angle. So if R is perpendicular to P and R is perpendicular to Q, then P is parallel to Q. Okay, so let's put these with some examples here. It says, given the following information, is it possible to prove if any of the lines are shown are parallel? So if we're talking about angles 1 and angle 6, they're going to deal with lines L and N. Well, angles 1 and 6 have a relationship of being alternate exterior. So I can say L is parallel to N by alternate exterior angles converse. Let's look at numbers 3 together. 3 says angles 2 and 3. Well, 2 and 3 are going to deal with L and M. They are alternate interior angles. And if they're congruent, we can say L is parallel to M by alternate interior angles converse. All right, let's do another one. 2 and 8. So this is a different picture. 2 and 8, they deal with A and B. These are also alternate interior. So we can say A is parallel to B by alternate interior angles converse. I'm totally okay if you guys want to shorten those words like alt, int, and use the angle symbol. I want you guys to try number 5 on your own. 5 says 3 and 11. Notice that 3 and 11 are going to relate with L and M, and they share this transversal here. I also want you guys to try number 6 out for me. So 5 and 6 come with those done. Number 7, in the ladder shown, each rung is perpendicular to the 2 rails. Is it possible to prove that the 2 rails are parallel and that all of the rungs are parallel? If so, explain how. If not, explain why. Well, right off the bat, I see from rung to rung, I have a 90-degree angle, and it's in the exact same spot. So if we look here, we are looking at the rungs being parallel. Because of that, we can either use corresponding angles postulate, or we can talk about our perpendicular transversal converse. So we can say the rungs are parallel by either the perpendicular transversal converse, transversal converse, or you could also think it's corresponding angles. All right, so let's talk now about the rails. They talk about the rails. Well, we're looking here at our rails, and I see that this is a 90-degree angle and this is a 90-degree angle. So we can say that our rails are perpendicular or parallel. I'm missing a letter. And that one's going to be by alternate interior angles converse. All right, so I want you guys to pause the video, do problem 8, come with that done for class tomorrow. Don't forget to go on and take your Schoology quiz, and we'll see you guys then.